We look far away, trying to find signs of intelligent life in the deep space. But while our technology is not advanced enough for this, we can look for primitive, though not highly evolved life within our solar system. If life is impossible on the gas giants due to the lack of solid surface and oceans, and Mercury and Venus are too hot, then we are left with Earth and Mars. If everything is clear with the Earth, what about Mars? Let's figure it out. What do we know about the planet? The fourth planet from the Sun, Mars. It is a close neighbor to our home Earth. Mars belongs to the terrestrial planets and is not like gas giants like Jupiter or Saturn, just like our blue marble. It has valleys and craters, canyons and mountains, and even polar snowcaps like those that cover Antarctica. Mankind has explored Mars using space observatories, interplanetary stations, and landing vehicles. Before the advancement of technology, however, scientists could only study the red planet at a respectful distance, and it excited their minds to such an extent that the period in history when 19th-century astronomers pointed their telescopes at Mars and made incredible speculations about it was called Mars fever. One English scientist of the time, for example, suggested that the dark areas on Mars were seas, and his French colleague decided that the changes on the surface of the red planet were due to changes in vegetation. But the strangest story came with the study of Italian astronomer Schiaparelli. He observed features of Martian relief, long, almost straight lines, and called them canali. This word in Italian means ducts, grooves, or furrows, but in English it was translated as canals. This is how the translator's mistake gave rise to the whole hypothesis that once upon a time there was a civilization of intelligent beings on Mars who created a system of irrigation canals in an attempt to save their dying world. Since then, science has moved a long way forward. No irrigation canals on Mars, of course. However, scientists are still questioning whether there were rivers and seas on the red planet in the distant past and whether liquid water can be found here now. The hypothesis that billions of years ago on Mars were much more favorable conditions for life, supported by a lot of evidence. Scientists suggest that once the northern hemisphere of the red planet covered the cold and salty ocean, with a depth of 1.5 kilometers. In addition, tsunamis even occurred on Mars. Astronomers found traces of 2 huge destructive waves that happened in different epochs. Presumably, the height of the tsunami reached 120 meters. Such a catastrophe could have been caused by the fall of large meteorites, but the raging water realm was left in the past due to abrupt climatic changes. The Martian Ocean completely evaporated. Today, there are no liquid lakes or rivers on the red planet, all because of the terrifying cold and low pressure at the surface. Instead of melting, the water immediately goes into a gaseous state, so only ice and vapor are present on Mars. That's what it is. But there is indeed enough ice, for example, under the Martian plain with the name Utopia. At a depth of up to 10 meters is a huge frozen lake. There is as much water in it as in Lake Superior, the largest freshwater body of water on Earth, located on the border of the United States and Canada. Too bad it's all hopelessly frozen. Much more chances to find on the red planet salty liquid water because thanks to its composition it cannot freeze even at temperatures below zero. So scientists do not leave their attempts. And in 2015, one of the physicists found dark streaks on the slopes of the Martian crater, very similar to streams. True later, it turned out to be a false alarm. Such traces most likely left behind streams of sand. Even if researchers eventually managed to find small puddles of salt water on Mars, this environment is likely to be uninhabitable. More recently, a team of American astronomers conducted computer modeling to determine this. The study took into account Martian weather data and the composition of salt solutions that can be found on the red planet. It turned out that even salt water could exist there seasonally and for a very short time, and it would also be very cold. It is unlikely that living organisms can survive in such conditions. However, in the search for life on Mars, scientists pay attention not only to water. It turned out that in the atmosphere of the red planet is present methane. This chemical element is an invariable companion of life, so in theory may well signal the presence of living Martian organisms. But methane in the atmosphere here is very little. It is necessary to find sources of methane and understand why its amount varies over time. But no one can guarantee that living organisms are responsible. Methane can also be released during complex chemical reactions under the influence of ultraviolet light. Another version. It could have been formed in the distant past and remained locked in the so-called clathrates. Over time, under the influence of external factors, methane is released into the atmosphere, where it is redistributed by the wind. However, there is still a long way to go in determining unambiguously what is the source of this gas. Although the red planet seems dead now, some 4 billion years ago it may well have had life. No, it's unlikely to have been inhabited by the same intelligent beings who built the canals. However, microbes were perfectly at home here. In ancient times, when Mars still had liquid water in the planet's underground streams up to 2 kilometers deep, lithotrophs could have existed. These small organisms, big fans of extreme sports, on Earth they prefer very harsh conditions, like the snows of Antarctica. To sustain their lives, lithotrophs harness the energy of inorganic compounds. For example, they can breathe iron. So the interior of Mars could well have been a cozy home for these microorganisms, and remain so for hundreds of millions of years. Nevertheless, on a cosmic scale, this time is not enough for the appearance of complex life. And in general, the existence of lithotrophs in the Martian past is just a hypothesis. It does not contradict the truth. But we don't know if that's what really happened. Astronomers still have a lot of gaps in the geologic history of the planet to say anything for sure. Well, if Mars is now an uninhabited planet with no signs of life, and it used to be, why don't we try to make the red planet something like our Earth, right? One of the founders of the Mars Society claims that terraforming Mars can be accomplished in 1,000 years, much faster than scientists have realized. According to scientists, this task can be accomplished by gradually transforming Mars into a habitable planet. Engineers plan to use the greenhouse effect to warm the planet by releasing greenhouse gases into the atmosphere. The first step in terraforming Mars is to build orbital mirrors that will reflect sunlight and heat the planet's surface. The mirrors are to be assembled in space and have a diameter of about 250 kilometers. Their goal is to raise the temperature of the polar caps to melt the ice and release the carbon dioxide that is trapped in the ice. The second stage would be to bombard Mars with asteroids with ammonia to exhaust greenhouse gases and release water. Nuclear-powered rockets will tether to the asteroids and propel them to Mars. The impact will release water from the ice. To raise the temperature on Mars by 3 degrees Celsius, about 40 asteroids need to be dropped on the planet. Then greenhouse gas factories need to be built that can be sent to Mars or created there. Engineers plan to replicate the Earth experience on Mars. But the difference is that on Earth, greenhouse gases are produced as a side effect, while on Mars they will be the main product. Mars needs to create a blanket of heat, and to do that, substances need to be released into the atmosphere. Scientists say that in 50 years the temperature will rise to 10 degrees Celsius. At the same time, gases will be released, raising the temperature another 10 degrees Celsius. On Mars, as the pressure increases and the weather changes, colonizers will be able to walk around without spacesuits. It will be possible to grow gardens and crops under domes. Temperatures will rise, bodies of water will appear, and plants can be planted. This is how we can theoretically turn a desert planet into a favorable one. And to learn more about how it will happen, you can learn in the video at the link. And if you liked the video, subscribe to the channel and comment. Bye.